Alright, the following graph illustrates the position versus time of a moving object. Using the graph, use the graph to answer the following questions. In what interval is the object moving towards the origin? Well, if we're looking at object that's moving towards the origin, we're looking at a negative slope. And specifically, we're going to be assessing the slope of the secant between 2 points, right? So you notice that the interval between C and D have a negative slope. So I'm going to draw the secant in blue. And there's also another secant. I'm just going to use a different color here. But there's also another secant with a negative slope between D and E. So both cases, the object is moving towards the origin, right? Because it's going back in direction. So it basically would have a negative direction. If we say that the position that is moving away from the origin is positive, the position moving towards the origin is negative. Okay, so this is going to be our positive direction for the time being. Okay, so positive directions are going to be shown by positive secant. So the interval in which the object is moving towards the origin could basically be between C, D, and E, right? So
you can turn the blocks here.
Thanks. Okay, so when we're considering the interval, we have to look at the independent variables. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I want to look at the interval between C, which is, it looks like 7.5, to E, which is 16. Okay, so I'm going to assume that time is in seconds and position is in meters. Okay, so in the interval that the object is moving towards the origin, the interval is going to be between 7.5 seconds. So T belongs to 7.5 seconds and 16 seconds. Okay, so in that case, we're basically looking in between the interval, because at the point of C, we're changing directions, and we also will change directions at point E. So I'm just looking in between the interval. So I have greater than 7.5 seconds, less than 16 seconds. Part B, in what interval is the object's velocity positive? So the interval is where the object's velocity is positive, and I'm going to show you guys this using a secant, a positively sloping secant. So you can notice here that these two secants, right, we'll call it slope 1, slope 2, right, slope 3. Okay, so in this case, the interval is where the object velocity is positive. It looks like, well, the first interval here, T belongs to 1 and 1 all the way to 7.5. Sorry, 0 all the way to 7.5, because it's going to encompass from point A to point C. Okay, as well as from 16 all the way to, and then this point here is going to be 17, 18, 19, 20. So 16 seconds all the way to, looks like 21 seconds. Okay, so 16 seconds all the way to 21 seconds. So we want to say both of these intervals are inclusive. So 16, excuse me, 16, 21. So union 16 and 21 seconds. So between the time of 0 and 7.5 seconds and 16 and 21 seconds. When does the object change direction? Well, we can see a change in direction at point C as well as point E. So when T is equal to 7.5 seconds, it'll change directions from going away from the origin going back towards the origin. Okay, so going from the positive direction back to the negative direction. And then in point E at 16 seconds, we can see that we change direction from D to E, which is going towards the origin, to away from the origin at E to F. Okay, describe the motion at the interval E and F. Because we have a constant slope of the position time graph, this indicates that our velocity is constant. Okay, so velocity is constant. The velocity function will have a constant slope as a result, right? A constant change as a result, right? So the velocity is going to be constant. This basically identifies the uniform motion. Okay, so this is important to understand. There is no acceleration as a result. So the velocity time graph at this case would just be a pure constant depending on what the slope of this line is, right? So if the slope was, for instance, 2 of this line, then the velocity time graph would be 2 at that point, okay?